Okay, calculus, we're going to go through 11 through 18 since it's been a while. These are, the first few are indefinite integrals, so that means we want an antiderivative equation plus c. So our options are going to be the power rule, it's going to be u substitution, or just ones that we know off the top of our heads, our flashcards. So let's look at number 11. This is a fraction. We don't have an antiderivative rule for fractions. We can't use the power rule. So we're going to pull this apart algebraically. We're going to rewrite this. So we are going to pull the 7 out front, and we're going to rewrite it like this. If we rewrite it like this, then we can easily take the antiderivative. So the 7 comes along for the ride. The antiderivative of 1 over x, we go to our flashcards, the antiderivative of 1 over x is ln absolute value of x. And of course, plus c. So there is your answer. The antiderivative of 7 over x is 7 ln absolute value of x plus c. Okay, let's go to number 12. Very similar. Again, we can rewrite this. Oops, gotta make that so you can see it. We're gonna rewrite it. We're gonna pull out the 1/3 and the x, 1 over x. Of course, x is still on the bottom. So there we go. So now again, to take the antiderivative, 1/3 comes along for the ride. The antiderivative of 1 over x is our ln absolute value of x plus c. And there you have it. So with a little bit of work algebraically, we can rewrite these, and the antiderivatives aren't too bad. All right, let's dial it up a notch difficulty-wise. Let's go to number 13. This is a fraction. There's nothing that we can do to pull this apart algebraically to make it any easier, so this is definitely going to be u substitution. The first thing we're going to do is pull it apart, rewrite it. Okay, oops, I'm still in highlighter mode. Okay, so we're going to rewrite this thing. All right, so when you have to rewrite it, we're going to put the numerator, which is x squared over 1, and we're going to put 1 over the denominator, which is x cubed plus 5, and then we have dx. So now we go to work. Let's review u substitution steps. If you have a fraction, always try to make u the denominator, because then you can get rid of the fraction. So my denominator is x cubed plus 5. So that's the first step, figure out what u is. The second step, remember, we write the differential. So the shortcut is u becomes du. We take the derivative here. So the derivative of x cubed is 3x squared, and then we toss dx on the end. So let's just go through those steps. U becomes du, you take the derivative, and you toss dx on the end. Okay, now we're going to go and diagram. The first thing we ask ourselves is where we're going to put in u. We're going to put in u right here. So this piece here is going to get replaced with 1 over u. Now we ask ourselves what's left. X squared dx. That's what's left. That's what has to be by itself right here. But we have 3x squared dx. So our adjustment is going to be to divide by 3. So our new and improved differential is going to be 1/3 du is equal to x squared dx. Okay, so now we're ready to rewrite everything. Let me get some more room up here. So we go to the fourth step. We're going to rewrite everything. So again, this piece here, 1 over x cubed plus 5, we're going to replace that with 1 over u. To replace x squared and dx, I'm going to go to my differential. Right here, x squared dx is now equal to 1/3 du. So 1/3 du. All right, now we're finally ready to take the antiderivative. All right, the 1/3 is going to come along for the ride. The notation is going to drop out. The only thing up there that we have to take the antiderivative of is 1 over u. And the antiderivative of 1 over u is ln absolute value of u plus c. All right, there we go. So again, 1/3 comes along for the ride. The antiderivative of 1 over u is ln absolute value of u. And now our last step is to plug in u. So 1/3 ln Absolute value, u is x cubed plus 5 plus c. And there you have it. Yippee! Okay, now remember, to check an antiderivative, we simply take the derivative. So I'm going to just walk you through that just on this one so you remember what to do. We're going to check by taking the derivative. So when we take the derivative, the 1/3 is going to come along for the ride. This is going to be a chain rule. My outside function is ln. My inside function is x cubed plus 5. So we go to work. The derivative of the outer is 1 over something. The inner as is x cubed plus 5. And the derivative of the inner is 3x squared. So now if you cancel out the 3's, you're left with x squared over x cubed plus 5, which is what we started with. So there is a review of u substitution. Okay, let's keep going. Let's do another one. 14. This is a very similar type of problem. It's a fraction. There's nothing we can do to simplify it to make it easier. So this is u substitution. Again, pull it apart. The numerator over 1, 1 over the denominator, and then dx. So let's make u the denominator again. X to the 6th minus 4. The differential, step 2, u becomes du. We take the derivative here, which is 6x to the 5th, and we toss dx on the end. So again, u becomes du. We take the derivative. The derivative of x to the 6th is 6x to the 5th. The derivative of negative 4 is 0, and then we throw dx on the end. Okay, now we're going to diagram. The first thing you ask yourself is where you're going to put in u. I'm going to put in u right here. Okay, this is where u is going to go. So this piece here is going to get replaced with 1 over u. So what's left? X to the 5th and dx are left. That's what has to be by itself here. So we need to get rid of the 6. So our adjustment is going to be to divide by 6. So our new differential is going to be 1/6 du is equal to x to the 5th dx. All right, now we're going to rewrite everything. So, fourth step. Again, this piece here, 1 over x to the 6th minus 4, is going to get replaced with 1 over u. To replace x to the 5th dx, I look at my differential. X to the 5th dx is now equal to 1/6 du. Alrighty. Fifth step, we finally take the antiderivative. The 1/6 comes along for the ride. The notation drops out. The only thing that we're taking the antiderivative of is is 1 over u, and that is ln absolute value of u plus c. And then you just have to plug in u. So I'm going to sneak over here. 1/6 ln absolute value of x to the 6th minus 4 plus c. There is your final best full credit antiderivative. How's it going? Coming back to you? Okay, let's keep going. 6. Again, we've got a fraction. Let's pull it apart. Put the numerator over 1. Secant squared of x. 1 over the denominator. 1 plus the tangent of x. And then dx. Okay, let's again make u the denominator. 1 plus the tangent of x. Step 2, the differential, u becomes du. We take the derivative. The derivative of 1 is 0. The derivative of tangent of x is secant squared of x. And we toss dx on the end. Well, that's going to be nice. Now when we go and diagram, this piece, this right here is where I'm going to put u. So this piece is going to get replaced with 1 over u. I have secant squared of x dx left. That needs to be by itself. It already is right here, all by itself. So there's no adjustment needed. Love that. All right, rewrite everything. Again, this piece, whole piece here, gets replaced with 1 over u. and I'm going to replace secant squared of x dx. I go to my differential. That is now equal to du. So this isn't too bad now. The only thing that we need to take the antiderivative is 1 over u. The notation drops out. The antiderivative of 1 over u is ln absolute value of u plus c. And then plug in ln absolute value of 1 plus the tangent of x plus c. There we go. And I could even do this. I could make my absolute value bars a little bit darker. There you go. Final, best, full credit answer. Okay, moving right along. 16, we'll go in order. 16, okay. Again, this is a fraction. There's nothing you can do to simplify it. Our only option is u substitution. So rewrite it. So again, the numerator, which is the cosine of x over 1 over our denominator, which is the sine of x, and then dx on the end. Okay, let's make the denominator u, sine of x. U becomes du. The derivative of the sine is cosine of x, and we toss dx on the end. Now we go diagram. Where is u going to go? U is going to go right here. So this whole piece is getting replaced with 1 over u. What's left? Cosine of x dx. That has to be by itself here. It already is. Yippee! No adjustment needed again. You're welcome. Okay, 4th step. Let's rewrite everything. This piece again, we rewrite it. That gets replaced with 1 over u. To replace the cosine of x dx, we go to our differential. All right, the cosine of x dx right here, that is all equal to du. So we replace it with du. All right, 5th step. Finally, we take the antiderivative. When we take the antiderivative, the notation drops out. The only thing to take the antiderivative of is 1 over u. The antiderivative of 1 over u is ln. Oops, yellow. I love yellow. ln absolute value of u plus c. And then we plug in u. ln absolute value sine of x plus c. All right. I want to try to make these absolute value bars a little bit darker. That's probably too dark, but you get the idea. Hey, let's check this one. Let's check. Let's take the derivative. So, the outside, this is going to be a chain rule. All right, when we check, it's a chain rule. That's the derivative. All right, my outer function is ln. My inner function is sine of x. So let's go to work. The derivative of the outer is 1 over something. The inner as is sine of x. And the derivative of the inner is cosine of x. And that's what we started with. All right. Moving right along. 2 more to go. Okay. Now, this is a definite integral. Do you notice we have endpoints, 0.5 to 4? So now, this is fundamental theorem of calculus. To solve a definite integral, there are 2 steps. All right. The first step, I'm going to go down here, a little bit more room, is to find the antiderivative. So we're going to call it g of x. What's the antiderivative of 1 over x, everybody? ln absolute value of x. And then for a definite integral, don't forget the brackets to bring along the limits of integration, the left endpoint and the right endpoint. Second step, we plug in the upper limit up on top of the bracket into the antiderivative, and then we plug in the left endpoint, the bottom of the bracket. So we're plugging those into the antiderivative. When I plugged in 4, I got 1.39. Make sure you're doing this. When I plugged in 0.5, I got negative 0.69. So my answer is 2.08. And that, of course, is an area. That is the area between 0.5 and 4 under the curve 1 over x. Remember, to check this, you can use Math 9, but you check with the original function. All right, the original function, the original integral. All right, because the calculator does all that work for you. So that's fundamental theorem of calculus, a definite integral. All right, last one. Okay, this is definitely going to be u substitution. Let's pull this apart. Numerator over 1, 1 over the denominator dx. Now, in this case, again, there's nothing to simplify. We can't avoid u substitution, but let's look at this. If I make my denominator u, if I make u the denominator, if I make u is equal to x, the derivative of x is 1. That's not going to help me replace ln x. This is a case where you're going to have to make u the numerator, because check it out. If I take the derivative of ln x, I get 1 over x. So this is one case where the denominator won't work. We have to use the numerator. So u is going to be ln x in this case. All right, u becomes du. We take the derivative. The derivative of ln x is 1 over x. We toss dx on the end. Now we go and diagram. Where am I going to put u? U is going to be right here. This piece right here is going to become u. So what's left? 1 over x dx. That has to be by itself here. It already is. No adjustment needed. All right, fourth step. We rewrite everything. ln x gets replaced with u. Again, this piece right here, ln x gets replaced with u. What am I going to replace 1 over x dx with? Hey, 1 over x dx, this whole thing here, is equal to du. So that gets replaced with du. Perfect. Now I'm set. Step 5, take the antiderivative. The notation drops out. The only thing that I need to take the antiderivative of is u. That's what we take the antiderivative of. And that is going to be a power rule. All right, so now we got to remember the power rule for antiderivatives. We add 1 to the exponent, so that's u to the first. So when we add 1, we get u to the second over 2. Plus c for an indefinite integral. The sixth step, pull out the 1/2 u squared plus c and plug in u. There we go. I hope that helps. Please shoot me an email or a text if there's anything that I can do to improve this digital or distance learning day 2. I hope you're doing okay. Keep in touch. Love you, calculus.